Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled, "The Universe is in a Death Cycle." Now, according to accepted theory, everything in the universe regenerates. Stars die, but not before going through some explosive event, which ejects large amounts of dust and gas away from the star. This gas then collapses under the influence of gravity, and eventually another star forms out of this dust. And what is left over then forms into planets. But the stellar cores which have invaded the solar system show us that something very different is going on. The stellar cores are dead stars and planets which absorb energy from the sun and other objects, which suggests that they are low in energy. They also have very low gravitational influence on other objects, suggesting that low energy is associated to low gravity. You may look at article 210 entitled "Stellar Core Gravity, Tidal and G is Not Constant." Some of these objects are extremely large, several times the size of the Sun, and you may look at article 265 entitled "Planet X Objects 3 times the size of the Sun." Even though what is left of them is mostly just the core of what was once a whole star or planet, at which time the core would be no larger than 20% of the size of the whole object. So a stellar core that is now the same size as the Sun is also now a core that is 5 times the size of the Sun's own core. And here we have an illustration of the Sun where we can see the Sun's core, which is 20% of the size of the Sun. And so this would be what is left of a stellar core. It's the core of what was once a star or planet, and so the object would have had 20% more material radius-wise on top of the core. But as it aged, it lost most of that material because its gravity gets lower, and so it ends up just being the core of the object itself. But even the core greatly expands in size. So if the object had been the same size as the Sun before, and it lost most of that material, what's left is the core, then and the object becomes just the core, that means that core has expanded to 5 times its original size. Thus, the stellar cores show that instead of collapsing gravitationally, objects do the opposite. They lose gravitational influence and expand as a result of energy depletion. The death of a star amounts to running out of energy. A star is born with a certain amount of energy in its core in the form of unstable nuclei that will decay and release energy for millions of years. But this energy eventually runs out and the star dies, turning into a stellar core in the process. So a stellar core is able to absorb energy from another star, but is never able to regenerate its reservoir and thus generate its own energy again. So there is no regeneration. Once the energy is used, it cannot be acquired again. The matter the stellar core sheds is also very low in energy, and it drains any other objects it makes contact with, thus spreading death. One of the important things that stellar cores have shown us, though, is that whatever happens at the microscopic level of the universe, i.e. in atoms and nuclei, also happens at all macroscopic levels. The principles regarding energy and interaction is the same at all levels. So what happens with atoms happens with stars and planets. Planets and stars have energy levels for electrons in their atmospheres just like atoms. This means that we expect that the energy transformation and interaction processes we see on stars will translate to stars of different sizes and to galaxies or galactic nuclei. Therefore, galaxies will also have a dense solid core and a negative outer layer, and will have a galactic wind, which will produce nebular clouds, but instead of just ejecting particles like protons and ions up to iron, the ejected matter will condense into much larger structures than ions. It will condense into stars and planets. And here's an illustration of a galactic nucleus, and it forms stars at its edge. And the stars are then ejected and move in orbit, in an elliptical orbit, around the galactic nucleus. So the star is propelled out into space, or ejected out into space following this orbit. But the star runs out of energy and dies at about here, which would be the aphelion position. So the star then goes back towards the galactic nucleus, or starts moving in that direction, but it's not seen anymore. And this is why galaxies does have these spiral arms, and that ends somewhere at the edge, seem to end at the edge of the galaxy. The truth is that there will be particles and stars that would be completing the orbit, but we do not see them. And this would at least partly explain why new stars ejected by the nucleus would be moving much faster at this position, close to perihelion, than everywhere else along the orbit. Now, so this is explained by James McKenney. This idea actually comes from him, and also detail it in article 215 entitled Dark Matter, Galactic Evolution and Star Formation. In addition, the fact that the galactic center must have a huge core means that it must be able to generate a lot more energy than individual stars, and thus must have a much stronger gravitational influence than individual stars. Thus, it is not the presence of a black hole that can explain the observed high speed of stars close to the galactic center, as accepted theory details. It cannot, in fact, be a black hole, because the existence of stellar cores indicate that black holes cannot form. But the fact that gravity is dependent on energy, and energy is dependent on the size of a core, means that galactic cores must generate a much stronger gravity than stars. And if they generate a much stronger gravity, it means that objects close to it, in orbit around it, would be moving at much faster speeds. So it's not the presence of a black hole that can explain the observed high speed of stars close to the galactic center. It cannot be a black hole because the existence of stellar cores indicate, as I said, that black holes cannot exist. But it seems that galactic centers just have a much stronger gravity than we would expect to find in stars, because they're just so much larger. But even a galaxy will eventually run out of energy and therefore die, just like stars and planets run out of energy and die. Thus, galaxies will eventually stop forming stars and planets, stop emitting light, and stop being able to attract all the dust, stars and planets it generated throughout its life. And thus, even a galaxy will eventually turn into a stellar core, or energy-depleted matter. In conclusion, the fact that stellar cores are depleted and thus dead objects indicates that all objects in the universe will eventually die. Stars, planets, and even galactic nuclei, and thus eventually all matter in the universe will become energy-depleted and die. Thus, the universe is in a death cycle. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.